In this episode, we will discuss weak electrolytes and influence of pH. Weak electrolytes and influence of pH. Weak acids and bases present in solution as non-ionized and ionized species. Here is equation describes the dissociation of an acid. Here is equation describes the dissociation of base. The molecule inside the red circle is non-ionized species. The molecule inside the blue circle is ionized species. Non-ionized and ionized molecule. Non-ionized molecule is more lipid soluble. They could diffuse readily across the cell membranes. Ionized molecule is less lipid soluble, unable to penetrate the lipid membranes. pKa. The transmembrane distribution of the weak electrolytes is determined by pKa and the pH gradient across the membranes. pKa is the pH at which half the drug or 50% of the drug is in its ionized form. Henderson Hasselbach equation is very famous. Here is the equation of dissociation of weak acid drug. From this equation, we could deduce the result. The ratio of ionized to non-ionized equal to 10 power pH minus pKa. When ionized equal to non-ionized form, in another word, 50% of the drug is in ionized form. The ratio of ionized to non-ionized equal to 1, so pH equal to pKa. It means pKa is the pH at which half of the drug or 50% of the drug is in its ionized form. From the weak acid drug, we could also get the result. When 50% of the drug in its ionized form, pH equal to pKa. We also could get this equation, the famous Henderson Hasselbach equation. For the weak acid drug, the ratio of ionized to non-ionized equal to 10 power pH minus pKa. For weak base drug, the ratio of ionized to non-ionized equal to 10 power pKa minus pH. Its famous Henderson Hasselbach equation. For weak acid, the ratio of ionized to non-ionized equal to 10 power pH minus pKa. For weak bases, the ratio of ionized to non-ionized equals to 10 power pKa minus pH. What is the use for? For example, here is weak acid drug, pKa equal to 3.4. Which condition is more easier to be absorbed? In gaseous use or in blood plasma? In gaseous use, pH equal to 1.4. In blood plasma, pH equal to 7.4. Here is a weak acid drug, so we use this equation. The ratio of ionized to non-ionized equal to 10 power pH minus pKa. In gaseous use, the ratio of ionized to non-ionized equal to 10 power pH minus pKa equal to 10 power 1.4 minus 3.4 equal to 10 power negative 2. It means non-ionized is 100 times more than ionized form. In blood plasma, the ratio of ionized to non-ionized equal to 10 power pH minus pKa equal to 10 power 7.4 minus 3.4 equal to 10,000. It means the ionized form is 10,000 times of non-ionized form. So, in this situation, weak acid drug is more easier to be absorbed in gaseous use than in blood plasma. For in gaseous use, more of drug are in non-ionized form. To get this graph, its influence of pH on the distribution of weak acid between plasma and gaseous juice separated by lipid barrier. Here is lipid barrier. This side is gaseous juice and this side is plasma. For a weak acid drug, we have calculated last PPG. In gaseous juice, more of the drugs are in non-ionized form. They are more easier to pass through the cell membranes. In plasma, more drugs are in ionized form. It's not easier to penetrate to cell membranes. So, for weak acid drugs are more easier absorbed from gaseous juice to plasma. Another example, look at this graph. Its influence of pH on tubular cell reabsorption and salicylate and amphetamine. Salicylate is non-steroidal anti-inflammatory drug. Amphetamine is powerful central nervous system stimulant. They could cause drug abuse. These two drugs we will discuss in later chapter. Salicylate is weak acid drug. Amphetamine is weak basic drug. The question is whether in acidic urine or in basic urine the drug is more easier to be excreted. For salicylate, when they are in acidic urine, more of the drug are in ionized form. They are more easy to pass through the membranes and be absorbed. When they are in basic urine, more drugs are in ionized form. They are not easier to penetrate the cell membranes and be absorbed. They are more easy to be excreted. For amphetamine, when they are in acidic urine, more of the drugs are in ionized form. They are not easier to penetrate the cell membranes and be absorbed. They are more easier to be excreted. When they are in basic urine, more of the drugs are in non-ionized form. They are more easier to pass through the membranes and be absorbed. So, when salicylate is overdosed and cause toxic effect, we should basify the urine to accelerate the drug to excrete it. When amphetamine is overdosed and cause toxic effect, we should acidize the urine to accelerate the drug to be excreted. Iotropion. At steady state, an acidic drug will accumulate on the more basic side of the membranes, and the basic drug on more acidic side of the membranes. We call it iotropion. Application. Application of this principle is made in manipulation of the drug excretion by the kidney. Almost all drugs are filtered at glomerulus. If a drug in its lipid soluble form during its passage down the renal tubule, a significant fraction will be reabsorbed by simple passive distribution. If the goal is to accelerate excretion of the drug, for example, in case of drug overdose, it's important to prevent its reabsorption from the tubule. This can often be accomplished by adjusting urine pH to make certain that most of the drug is in ionized state. As a result of this partitioning effect, the drug is trapped in the urine. Thus, weak acids are usually excreted faster in alkaline urine or basic urine. Weak bases are more usually excreted faster in acidic urine. Look at this table. It's ionization constant of some common drugs. Every drug has its own pKa. Here is weak acid. For example, acetaminophen, its pKa is 9.5. Aspirin, its pKa is 3.5. For weak acids, its pKa could be less than 7 or larger than 7. Here is weak bases. For example, lidocaine, its pKa is 7.9. Chlordiazepine, its pKa is 4.3. For weak bases, its pKa could be less than 7 or larger than 7. Multiple choice. 1. Which drug is easier to pass through the cell membranes? A. ionized form? B. Non-ionized form. The answer is B, because non-ionized form is more depreciable. It's easier to pass through the cell membranes. 2. When the weak acid drug is overdosed, how to accelerate it to be excreted from the body? A. Acidize the urine. B. Basify the urine. The answer is B, because the weak acid drug in basic urine, more of the drug is in ionized form. It's not easier to penetrate the cell membranes and absorb. It's easier to excrete from the body. 3. Weak basic drug is more easier to absorb in A. Acidic condition. B. Basic condition. The answer is B, because the base drug in basic condition, more of the drug is in non-ionized form.